We're going to use this new tool that sculpts and removes the extraneous information that we have on the side, uterus and placenta, and that's called A-reveal. And watch what A-reveal will do to this volume. It helps to illuminate and show the face off in a quick fashion without having to sculpt any information. Touch view is very interesting because instead of using rotational knobs to change the volume, you can simply use your hand. And not only can I rotationally use 2 fingers to move this in a Z plane like that, I can use a single finger to move the volume in an X as well as Y plane. And then we are going to bring up touch view to be able to put the light and drag the light for the patient, yourself, around the volume in an intuitive fashion, just like any smartphone at home. You can double click and place the light in multiple different places, and you can also bring the depth of the light in to provide some unique shadows and illumination to the fetal face. I can also rotate the baby using 3D touch view. You can see how the shadows move in a realistic fashion, in a very smooth and fluid fashion using touch view, available on the Philips, Epic, and Affinity systems. True view is quite remarkable. You really get a true sense of what it would look like in absolute photorealistic fashion. The colorings, the shading, the tones are truly realistic. When we move to true view imaging, we have this pink hue that alone is simply coloring. But as you can see, what I've done here is I've brought the light actually within the left ventricle using the depth capacity, which is unique to true view, and allows the light to enter along a Z-axis. And the light here in the left ventricle, as we've placed it there, allows us to see an illuminated left ventricle, the mitral valve. And what's very interesting to me is that the light actually penetrates into the left atrium, illuminates the top portion of the wall of the left atrium, but does not at all enter the right ventricle with no penetration through the ventricular septum, so that the light is actually acting as it really would if I put an orb of light within the actual cardiac volume. This personally helps me have a bit more confidence that there is no evidence of ventricular septal defect, and if there were, we would anticipate seeing light emanate into the right ventricle. So as we see glass view and we move into glass view analysis from true view, I think of glass view as looking at kind of a plaster of Paris poured into the cardiac volume and then removing the cardiac myocardium and being able to look into the chambers, the volume of the chambers, kind of in a translucent fashion. For me, what I can identify here is the left ventricle. I can see the aorta leaving the left ventricle, the right ventricle, and the pulmonary artery leaving. But what's particularly important in this imaging is that there should not be any fluid coursing across or any evidence of a chamber coursing across the intraventricular septum, and I actually do not see that, which I believe is a good thing, again helping us provide clinical confidence that this is an intact intraventricular septum and that this is a normal cardiac septum present in this volume. And that to me is one area in which glass view can shine and provide some clinical confidence for you and your patient. Philips has provided us with tools that were incredibly useful, faster, better imaging. All right, we're going to do a demo of Biometry Assist technology on the Philips Epic and Affinity systems. And what I have on the monitor here is an image of the fetal head. And I'd like to walk you through capturing both the feed from the screen as well as what goes on the touch screen. And so traditionally we have to use our left hand and click measure, and I'm going to change this to manual to simulate what we would do in a manual fashion. So again, click measure, maneuver the calipers to the upper portion of the biparietal diameter and move it down to the inner portion of the biparietal diameter, and then select the biparietal diameter and then hit acquire. Next, we will have to click measure again, bringing up another caliper, select the front portion of the head for the occipital frontal diameter, the back portion of the head for the occipital frontal diameter, accept those measurements as the OFD and then acquire. So using the trackball and having to do this. We're going to then erase these, and I'm going to deploy and measure the head circumference. So we're going to click head circumference, and what you're going to see is I again have to use my left hand a bit, maneuver over to the back of the head, alternate the ellipse and select and maneuver the ellipse to make sure I'm happy with that, and then actually acquire that measurement. So next we're going to measure the abdominal circumference, and I'll show you how that works in a manual fashion. So we have our abdominal circumference, and I'm going to select abdominal circumference, and now I need to measure it. So we place the caliper at the front of the abdomen, we place the caliper at the back of the abdomen, we make the size of the ellipse slightly smaller to work around the belly, and you can see this requires sometimes a bit of manipulation, and we finally accept that. Now we're going to go and find our femur. We identify the femur, and let me show you how we're going to measure that manually. So we're going to have our femur, and traditionally we would click measure, come to the lateral epiphyses here, and track over using the trackball again, just taking time to find that correctly, and hit femur length and acquire. I'm going to erase this and show you what this would look like using Biometry Assist. And so we're going to turn that on. And again, I'd like to measure the biparietal diameter. I'm going to push one button. I'd like to measure the occipital frontal diameter. I'm going to push one button. I'd like to measure the head circumference. And the head circumference is measured with the tool, using simply pushing the button and not adjusting anything with the left hand, as the anatomical intelligence identifies the structures that we need. To our next image, and we need to select the belly. Instead of measuring the entire ellipse, adjusting it, we've collected and frozen our abdominal circumference image. We're going to press the AC button, and the abdominal circumference deploys perfectly, and we accept that. We are simply going to hit the femur length, and it deploys in a perfect fashion, measuring the bone the way we would want, without any manipulation using the roller ball or the touch buttons on the machine interface. We have seen a significant reduction in keystrokes, and we have also seen a reduction in actual time.
walls IMT. Press Measure and then select the right common carotid folder on the touch panel. Next, select the Auto IMT FAR to make the IMT measurement for the posterior wall. Position the measurement cursor inside the vessel lumen using the trackball and click Set to anchor the initial measurement point. Next, move the trackball horizontally, left or right, to extend the measurement length. Roll the trackball downward slightly to incorporate the intima media of the additional posterior wall into the measurement zone. A rectangle or parallelogram will now be displayed. Click Set to finalize the endpoint of measurement, and the measurement results will be displayed.